video, we're going to cover the rest of the fundamentals of functions and relations. We're going to cover what are functions and relations and how do we express them. We're also going to cover the key properties of functions and relations, including the domain and range, the difference between one-to-one versus one-to-many functions, and we will cap things off with an introduction to piecewise functions. First, let's cover relations. Put simply, relations describe how two sets of numbers interact with each other. When we write the equation y equals x plus 3, we're drawing a relationship between the set of numbers x and the set of numbers y. We usually describe relations using interval notation as follows. We start by defining the input and output variables. Usually, x refers to the input of the relation and y refers to the output of the relation. From there, we write the expression. The expression tells us how we modify the input to create the output. In this case, we have the relation y equals x plus 3. If we give the relation an input of 1, then the relation will add 3 to that input and produce an output value y equals 4. Finally, we write the domain of the function, which in this case is all real numbers. But what is the domain? Relations typically stretch onto positive and negative infinity, but in most cases we're only interested in a small part of the graph. If we want to, we can restrict the relation by defining its domain. The domain of a relation defines the set of inputs that the relation is valid for. In the example before, we said the domain was all real numbers. This means that we can feed any real number to the relation and get a result. The range of a relation is the set of all output values after taking into account the restriction of the domain. Using the example from before, the relation y equals x plus 3, if we limit the domain between the numbers 0 to 1, then the range of that relation becomes 3 to 4. The maximal domain of a relation is the set of all possible inputs to that relation. This basically means all possible inputs that don't break the laws of math for that relation. A typical restriction on the relation is a divide by 0 error. For example, the relation 1 on x can't have the value x equals 0 because then we will be dividing by 0. Hence, its maximal domain is all real numbers excluding 0. If the domain of the relation isn't specified on your test, then you have to assume it is the maximal domain. Now we get to take a look at functions. This is the bread and butter of what you'll be doing throughout Year 12 math methods. Functions are a subset of relations. A function is a relation where each unique value of x produces a unique value of y. You can use the vertical line test to determine if a relation is a function. For example, the relation x squared is a function, but the relation x squared plus y squared equals 1 is not. Notice how the vertical line can only intercept with x squared once, but it can intercept the circle twice. Functions are typically expressed in two main ways. We can either use simplified notation or we can use explicit notation. True to its namesake, simplified notation is the simplest way to express a function. We start by naming the function and then we declare the input variable. The generic name for a function is f of x, where we've called the function f and we say that its input variable is x. Notice how there's no domain. That's what makes this the simplified approach. In this case, we have to assume that the domain is the maximal domain. For example, suppose we have the function x squared plus 1. Suppose we want to know the value of f of x when x equals 2. To do this, we replace x everywhere in the function with the value 2, and then we simplify the result. If we want to apply restrictions to a function, we'll use explicit notation. As before, we have to give the function a name. In this case, we've given it the name f as typical. Here's where it differs. We now specify the domain and the codomain. The codomain of a function is the set of all possible outputs of a function over its maximal domain. We then finish up as per the simplified notation. For example, suppose we wanted to restrict the domain of the function 1 over x over the domain negative 5 to 5, excluding 0. We could do this as follows. Now, as a reminder, this expression uses set notation. The backslash is used to exclude numbers from the set, and the capital letter R suggests that the codomain is all real numbers. So what exactly is the difference between the codomain and the range? The codomain and the range both describe the set of possible outputs of the function. The key difference is that the range is defined by the domain, but the codomain is defined by the maximal domain. If the domain and the maximal domain are equivalent, then the codomain and the range must also be equivalent. Let's start with one-to-one versus one-to-many functions. A one-to-one function is a function where each unique input produces a unique output. That is to say, if you're told the output of the function, you should be able to reverse engineer back to what the input must have been. You can't do this with a one-to-many function. You can determine if a function is one-to-one or one-to-many with the horizontal line test. If you can draw a horizontal line anywhere on the function and only intersected that function once, then that function is one-to-one. Otherwise, it's one-to-many. For example, the function x squared is a one-to-many function because that horizontal line can intersect twice. However, if we look at the function 2x plus 1, we see that it is one-to-one because we can draw a horizontal line anywhere along that curve and only intersect with the function once. Piecewise functions are quite unique. These kinds of functions have a unique expression for different parts of its domain. The general form of a piecewise function is written as follows. As usual, we have to give it a name and we have to declare the input variable. This is then followed by a series of expressions and their corresponding domains. For example, consider the following piecewise function. Its value is 0 for all x values less than 0. It then has the rule 2x plus 1 over the domain 0 to 1. From then on, it has the rule negative x plus 4 for all x values greater than 1. The domains of a piecewise function are not allowed to overlap. Notice the specific use of inequality signs. The horizontal dash under the inequality sign tells you if the value is included or excluded from the interval. In this case, the values 0 and 1 belong to the domain of the second expression. Alternatively, the domain could have been expressed using rounded or square brackets, where the rounded brackets mean that the value is excluded from the interval, whereas the square brackets represent that it is included in the domain. And that brings us to the end of Functions and Relations Fundamentals. If you found this video helpful and would like to see more, I have a Google Drive with written versions of lectures just like this, covering the entire Year 12 Math Methods syllabus. Just click the link in the description below and it'll take you to my website. Just scroll down a little and click this heading to get access. No opt-in required, free of charge. In the next video, we'll look at how we use and solve polynomial functions. See you there.